Good evening.
You are from our state, West Bengal only.
Yes.
You are based in Mohanpur, I believe. Huh?
Yes.
And I passed out from Vidhan Chandra Krishi Vishwavidyalaya, my bachelor course also.
Oh wow. Yeah. Next door neighbors too.
Yeah.
Okay.
So are we taking questions after 15 minutes presentation, right, Mr. Chakravarti?
Yeah, I think I will just take couple of minutes only to
No. This is after each speaker.
I don't think there's time.
I think after 15 minutes we can have one or two questions after the session, and then we can go for the next one.
Okay. All right.
Dr. Shilanjan has joined. I have to say.
Yeah, can you hear me?
Yeah, Dr.
Hello.
Yes.
Yeah, hi, Shilanjan.
Hi, Raman.
Shilanjan. Good evening, Dr. Shilanjan. How are you?
I'm fine now. Yeah, my laptop has crashed just a few minutes ago, so I'm depending on this Android.
No problem. Your images are in my slides, so as soon as you say.
If I need, I will ask you, please. Thank you, Sinu.
Yeah, fine. Yeah. Mr. Chakravarti, all the three speakers, one way or other, is related to IISc. So Reni is still in IISc, and Robert was a graduate student.
Hello everybody, so welcome you to this session on building climate resilience for vulnerable landscapes. This is the day 2 of the 14th edition of the Bengal Chamber's annual Environment and Energy Conclave. We are very happy to have Mr. Jayanta Chakraborty, Chairperson of our Agriculture and Rural Development Committee of the Bengal Chamber and Senior General Manager of Indophil Industries Limited. I would request Mr. Chakraborty to please commence the session with his opening remarks and then take forward the proceedings. Thank you.
Thank you, Angana, for giving me the chance. Welcome all. I think the theme of this year's 14th edition of Annual Environment and Energy Conclave is Journey Towards Net Zero at the Threshold of COP26. The Annual Environment and Energy Conclave, an international forum for climate change mitigation and business response, is held every August and is the preferred forum for discussing environmental and climate challenges and mitigation actions. With the 14th edition, the Chamber endeavors to curate a movement for sustainability and journey towards net zero at the levels of policy, business, society, and individual. UK, USA, and Australia are the partners this year. The focus of the conclave this year is to create an international policy advocacy forum towards net zero by bringing in policymakers, thought leaders, captains of the industry, entrepreneurs and innovators, academicians, and torchbearers of civil society. The conclave would create a forum to brainstorm, showcase, engage in dialogues, and initiate collaborations. This session is on building climate resilience for vulnerable landscapes. I think we have selected 3 important vulnerable landscapes of India. One is Himalaya, second is Sundarban, and Western Ghats also. And we have eminent 3 speakers with us, along with the moderator, Mr. Dr. Palati Alesh Sinu. Just giving a small profile about Dr. Sinu. Dr. Sinu, an inspired faculty of Central Versities by the Rashtrapati Bhavan, New Delhi, is currently Assistant Professor of Geology at the Central University of Kerala in India. His research interests are broadly in plant-animal interaction, conservation biology, insect science, and environmental policy studies. He obtained his PhD from the University of Calicut, Kerala for his work on the effect of land use change on insect pests and insect natural enemies of rice paddy agro-ecosystem in the Western Ghats. Thereafter, he moved to, in between, he has worked in Tea Research Association, Jorhat also. He is also a postdoctoral fellow of the University of Arizona, USA. His lab involved in the research on plant-animal interactions, studies, insect biodiversity, and land use policy analysis in the Western Ghats and the Eastern Himalayas. He is an author of over 80 research papers of international repute and 3 books and chapters. Dr. Senu will be the moderator for today's session, which is the Building Climate Resilience for Vulnerable Landscapes. We are having wonderful 3 eminent personalities in this session, which I think Dr. Senu will introduce in due course of time. So I request Dr. Senu to take over from me for this program. Dr. Senu, please unmute yourself kindly.
Hello, am I audible?
Yeah.
Okay, all right. Thank you, Mr. Chakrabarti, for giving me a chance to organize this very important topic along with you for the Bengal Chamber of Commerce and Industries. I consider it as a privilege to organize this this symposium for the Chamber associates as well as for the public. So as we all know, this is the year, again, the IPCC came up with a projection that no land is spared from the climate change. So I just want to share a few of my 3 of my slides actually, just to introduce this theme. Is it viewable?
Yes, it is. It is.
Yeah. So we, with this thought, we come up with a session on this climate resilience for vulnerable landscapes. But what is vulnerable landscape? We are covering in this symposium the 3 important landscapes, so that is the Himalayas, Western Ghats, and the Sundarbans. But let me tell you, the climate change is spared no lands unvulnerable. That means all the landscapes around India is vulnerable. Even IPCC projects are so. I just want to tell me my personal experience with the state of Kerala, where I live in very much close to the city of Ernakulam, and you can see the aerial view of this city in 2018 flood. So it says that no land is spared from this climate wrath. We have all stakeholders participating into it, and also the reasons for it, and also have are given or bestowed with the duty of managing our landscapes. So as Mr. Chakravarti told, I was working in the tea industry. I find one of the impactful research, I'm so happy to tell that the Northeastern tea, unlike the South Indian tea, conserves a lot of biodiversity, including the vegetation cover, as you see in this picture. A hectare land of tea has more than 500 plants or trees, which is giving the good shade. But it also has a very much role in the conservation of the biodiversity, sequestration of carbon dioxide, etc. So this is again another important area, the urban landscapes, where you see the urban landscapes are flooded again by this ongoing climate change and incessant rainfall across. So with this introduction, I have 3 eminent speakers here. As we move on from the, it says that one of the impact of climate change, the species are migrating towards the north. But today we are migrating from the north to south, and we'll begin with the Himalayas. And Robert Chandran will be speaking about the how the Himalayan stretch, the tracts, are vulnerable from this climate change and related issues. So I just introduced Robert Chandran. He is a PhD holder and from Indian Institute of Science, and worked on the plant systems and prolifically. And later he had a couple of postdoctoral fellowships abroad in the United States and returned to Italy, where I met him and where we had collaborative works. And now he is an associate professor in the Indian Institute of Science, Education, Research in Kolkata. And he is actively involved in research and outreach and the capacity building of the people living in the Himalayan stretches. One of the grantees of National Mission Himalayan Studies and also the DBT's program. I guess he is the apt person to talk about how vulnerable the Himalayas is from the ongoing climate issues. With this brief introduction, I invite Robert to share his PPT and to talk more about. Later, I will introduce Dr. Silanjan and Dr. Reni as we move on further. Thank you. Over to you, Robert.
Okay. All right. So, good afternoon, everyone. Thank you, Sinu, for that kind introduction and for inviting me to speak here. I hope you can see my screen.
Yes, Robert. Yeah.
Okay, great. So, yeah. So, as Sinu said, no land is spared, and certainly not the Himalayas. So, we have seen a lot, I think.
Robert, make it full screen, please.
Yeah,
make
yeah.
it full screen.
So as Sinu was saying, no land is spared by climate change, and he also mentioned the 6th assessment report that has just come out, which sort of reaffirms what we've been saying in the last couple of decades or so, that the human contribution to observed climatic changes is the predominant one. If the human contribution were not there, we would be somewhere there, but clearly we are quite away from it. And so we can keep arguing about exactly what is going to happen in the future. There are some good projections, and none of them are really good. So we have a lot to work in terms of trying to, stop this or mitigate the worst effects of climate change. And certainly, what we are seeing now has never been seen in the last 2,000 years or so. So there's a clear climatic signal that is caused by human activities. Now, just to summarize, that this climatic changes that we are talking about is not something that we have to fear in the future. It's already happening. And it's happened long enough for us to figure out and quantify some of the changes that have already been seen and attribute those changes to the different causes. And as far as human contribution is concerned, that's the primary concern here. And if you look at the global land surface, and lay these hexagons out to define different regions, and our region is South Asian region over here. And you see, if you look at extreme weather events, obviously mean values of temperature and rainfall and all that have been changing for sure. But what is also equally or more damaging is these extremes of heat and precipitation. And here are regions that have shown increases in observed hot extremes. These are observed data. These are not projections of what is going to happen. These are actually observed things. And these dots here indicate the level of confidence we have in attributing this to human contributions. And 3 is very high. So we are pretty certain that these extremes are caused by human activities. And so across the globe, all land surfaces pretty much have seen these hot extremes. Now looking at precipitation, again, we have a similar story, not so extreme like temperature, but yet we see increases in precipitation largely, but also decreases, probably no decreases anywhere. But there's also a lot of regions where we can't really attribute the change because of low confidence with the data. And as the data come in the future, we can say with more certainty about what's happening. And so again, you see here that the South Asian region is a region which is affected already by heavy precipitation events that we have in fact noticed in our own, as Sinu showed some slides about flooding and so on, which are a direct contribution of these heavy precipitation events. Now, the thing that concerns us is agricultural and ecological drought, extreme dry periods. And again, there are regions where there's a certain increase in agricultural and ecological drought attributable to human causes. In the South Asian region, we don't have enough data to suggest one way or the other and to say with confidence if it's human contribution. But again, I view these as knowledge gaps really, and not something that we should be complacent about. That things could be happening that we haven't seen yet, and it could come up in a strong way in the future. So these are observed changes, and it's happening all across the world. Now, of course, our concern here and my focus here is on the Himalayan region in India, and perhaps actually Himalayan region across the entire globe. So the focus on India being that the MOES came out with a report in 2021, a recent report, which basically says that average temperature over the entire Indian region has increased by about 0.7 degrees during this period. That may not seem a lot, but it's average temperature. So we'll have to, that's quite a lot when you consider average temperature. So there are other numbers here which I don't want to spell out because for lack of time, but it's not so good news because things have been changing and change is sometimes not always good. So particularly with respect to extreme events and the frequency of droughts, for example, all of these are changing in the wrong direction, which can cause problems for people and for ecosystems. Focusing on the Himalayas, and typically climate scientists define something called as the Hindu Kush Himalayan region, which is a very large region extending about 3,500 kilometers or so east-west, and then includes a lot of area in the Himalayas and the Tibetan Plateau. And so obviously this is an extremely diverse region, and it's hard to make generalizations that may hold across the entire region. But it is done because it's difficult to make very fine-scale predictions or fine-scale analysis either. Now, overall, there has been an increase in temperature, which is more than what has happened in the rest of the Indian subcontinent. Here, the average temperature change is about 1.3 degrees Celsius over the entire region. And of course, some regions experience more than others. There's also decline in snowfall, particularly in the winter months. And the warming has led to the retreat of glaciers for sure. Now, the western region and the eastern region are somewhat different because of the differences in latitude and all that. This is more tropical than this. And the western region receives more winter rainfall in the form of snow than the eastern regions, where the eastern regions receive mostly the summer monsoon rain. Over 80% of it is like that. So it's important. The distribution of rainfall is important because of the snow that falls in the winter over here is the snow that contributes to melt and discharge of rivers later on in the summer. So these patterns have also been changing. Now, a quick summary of the temperature anomalies over the Hindu Kush Himalayan region, or 5-year running averages. So you see that things start to change really in the mid-80s, right? So before that, there's been ups and downs, but in the mid-80s, there's a clear departure from the longer terms, variation that we see. So this is for the Himalayan region, the light colors and the brighter ones for the entire India. So you see the Himalayas are getting hit more than the rest of the subcontinent. And then as far as elevation is concerned too, the higher elevations are experiencing more warming compared to the lower elevations. So that's another factor that we need to sort of consider. So these are observed changes, patterns that we have seen up to say 2016, 2020. Now, what about projected changes? Now, this is complicated because it depends on the emission scenarios into the future. So it depends on the decisions that governments make now, which will determine, or people make now, which will determine the extent of emissions into the future. And so there are two particular scenarios which are plausible scenarios. Representative concentration pathways, which are essentially the two pathways that are often analyzed is 4.5 and 8.5, which corresponds to 4.5 or 8.5 watts per meter square radiative forcing, the extent of radiative forcing for the atmosphere. Now, the news is that for the Hindu Kush Himalayan region, if you look at temperature within the 2040 to 2069, you're likely to see that the average temperatures breach the 2 degrees Celsius mark, and perhaps more into the future. But if you look at a more greater warming scenario of 8.5, you're going to see much more. Now, this is quite alarming if this truly happens, really. And with rainfall too, you're going to see 6 to 10% differences in increase in annual precipitation, or in the lower warming scenario, you would see about 3 to 7%. Now, I don't want to go on talk about the rest of India, but these are actually fairly robust numbers because the models that are used to predict now have gone through various stages of development. This is the 5th phase called CMIP5, and this can actually do very long-term simulations of the 20th century changes, and then also do projections into the 21st century and way beyond. So we have very good level of confidence in predicting these changes over regional areas of the globe. Now, why is the Hindu Kush Himalayan region really important, right? It's important for various reasons. One is, of course, there's a huge number of people live in the region, more than 1.3 billion or 4 billion people. But this is a driver of the strongest monsoon system in the world. Really, the Tibetan Plateau, along with this, the changes in this region have a very strong influence on the strength of the Asian monsoon. Now, it's also a source for 10 major river systems. I'll show you a map of these river systems. It's also the largest reservoir of ice outside the polar regions, and is often called as the third pole. It's part of biodiversity hotspots, and then there's also a lot of cultural and diversity in this region. Now, so this makes it really important because of the major river systems and all the influence it has on global scale phenomena. So, that's really an important thing. Now, as far as projected changes for this region are concerned, again, there's a quick summary that I wanted to give you before I move on to resilience issues. So, surface temperature across the Himalayan region will likely increase, as we see here, going from 1950 to 2100. Precipitation and snow cover, snowfall will also change, and snowfall largely due to winter snow might decrease. So these are changes that we have some fairly high degree of confidence in working with in the future, for the future. So as I said, in building climate resilience, the first step is to understand the threats that it poses to life and the economy. And climatic changes are already affecting multiple dimensions of life across the Himalayan environment. Human health and well-being are primary, of course, and that there are direct and indirect impacts on human health and well-being. There's also important. Another important aspect is agricultural productivity and agricultural incomes and livelihoods. Then there's also forest-based livelihoods that people depend on in this region. Then water resources and water security. Then the problem of extreme catastrophic events, and we have seen that in the recent past, landslides and flash floods and so on. The outbreak of pests and diseases in agriculture and animal husbandry, which doesn't make huge news, but if you go work in the region, you'll see that this is a serious problem. And then, of course, agroforestry and horticulture and other systems that have been traditionally the mainstay for people before intensification of agriculture. And then there are, of course, energy-related matters. So you need to supply energy to people who live there. Now, all of these things will be affected by climatic changes, have already been affected. Now, if you want to build resilience across all of these, then you need to build resilience across all of these dimensions, right? And so what exactly do I mean by resilience, and how are we going to achieve that? So that's the key today. So we know that climate has been changing. We know that it's having impacts, and I've tried to quickly summarize that. Now, what can we do about it? How can we deal with it? How can we adapt to that? Now, Now, when people say climate resilience, they usually mean that it's the ability to anticipate changes. And that's what we do by all this analysis of data and global scale models, is to be able to anticipate changes at global scales as well as local scales. And of course, to prepare for those changes and to be able to respond to those changes as well, right? And then to pick up trends that may be present in the long run, and disturbances that might arise due to changes in climate, right? So this is a basic thing that we need to do to build climate resilience in societies. Now improving climate resilience therefore involves assessing how all these changes will create new or alter current climatic risks, right? So things keep changing. It's a very dynamic thing. And so we need to keep reassessing the risks and the impacts that these changes will have. Now, anticipating changes, the first step, we have done reasonably well. At the global scale, we have analysis and predictions that I just showed a few of them. But we need to do better. We need to do better in order to be able to plan for changes or interventions at local scales or regional scales. And so the gaps in understanding, for example, for the Himalayan region would be that downscaling methodologies, when you downscale to individual river basins, to work on individual river basins, then there are limitations, right? You can say something about the entire region, but when you want to speak about specific regions, there are problems. Then the big issue of aerosols, black carbon, there's not enough data to be able to assess its impact on the Himalayan region. So these are some gaps that we need to fill in the future. But we have a reasonably well understanding of what to anticipate in the near and distant future, really. So what can we do? And coming from a background in plant and forest ecology, I have a bias towards the primary problem in the Himalayan region, and that is deforestation and degradation. Now, the Himalayan region, as this image might sort of tell you, I don't want to draw your attention to these points over here, but just the green background, which tells you the extent of forest cover. Now, overall, the forest cover, if you ignore all the cold desert areas where trees anyway cannot grow, the forest cover is quite extensive, more than 50%, sometimes 75%, and so on. Now, so that forest cover is really important because that constitutes the matrix in which all the other human activities are embedded, whether it's agriculture, agroforestry, or urban settlements and all of that. And then more than in rest of the subcontinent, this matrix is important for maintaining the integrity of these systems. So if you destroy that matrix through deforestation or degradation, you're going to seriously compromise the ability to carry out any other activities, whether it's agriculture or other forms of development. Now, the projections are that if trends continue, the Indian Himalaya could lose over half its forest cover within the next century. Right? That's a long time, but the trends are pretty clear that this cannot continue. This has to be addressed and taken care of. Now things get a little complicated. Now, here is a recent paper just published this year, which summarizes some of the changes in the Himalayas across many countries, of course. It's a meta-analysis which basically summarizes the transformations that have taken place from 1992 to about the current 2018 or so. And I draw your attention only to the Indian region. So we're looking at 218,000 square kilometers of land area with about 132,000 square kilometers or so of forest cover. The forest cover is pretty high, really, and it has not changed apparently much in terms of net change from 1992 to 2018. In fact, the net change of forest cover is positive, as we appear to have gained about 900 square kilometers or so of forest. So that's sounds like a positive thing. Why are we so alarmed about deforestation? But the devil is really in the details, in the spatial variation. So this net change is actually a result of a fairly high dynamism in terms of forest loss and gain. So we have lost over the same period close to 4,600 square kilometers of forest, and we have gained a somewhat larger amount, 5,400 or so. Now, anybody who knows ecology would just get alarmed about these things. So we lose forest, we know what happens. But gains are not necessarily equivalent to the losses, and that adds up these numbers. And it's hard to recover the diversity and function of primary old growth forests that are lost. Usually have secondary formations with a few tree species that appear to be counted as forests, but they're not some equivalent to forests in terms of their diversity and ecological function. And that's rarely ever measured or tested. So this is not so good news, not so very bad either, but there is an opportunity here to do things differently. Now, what these numbers sort of hide is also some changes that keep happening really in terms of disturbance, in terms of transitions. So this is one of my own studies which have shown the increase in agriculture has been at the expense of primary forest. So these changes are happening, and one of the biggest threats quickly is large-scale development that is happening in the Himalayas. Like the Himalayas can take smaller scale changes, but large-scale interventions such as these is a big threat, I think. And what we have are like quite a lot of dams that are being planned in the Himalayas, close to 400 dams in the entire region. And so this could have a huge impact on all these river systems. So these major river systems, about 10 river systems in this region, which are all being subject to huge modifications of their hydrological regimes. So here's the numbers of dams, 292 for India as it stands, 100 or so in the Chinese region. And when you look at these numbers, you know that it's one-upmanship and not transboundary cooperation. This cannot be in the best interest of the region, because in fact, anybody and everybody who has written about it will say that no one can claim that we understand the impact of these dams on the Himalayan ecosystem. But it's happening because there's no transboundary cooperation in this particular regard. Now, looking at the Indian region itself, you see the number of dams that are being proposed all across this, and the red dots indicate sites where dams are being proposed in high biodiversity regions. Now, nobody knows, and no environmental impact assessment has been done to investigate exactly what the impacts of these dams would be. But there is a push towards projecting hydroelectric power, hydropower as a clean energy platform, which again is a questionable thing. I don't have time to cover that, but this is an important consideration. Now, just to summarize quickly, the changes that we've been seeing in the Himalayan region, in the forest matrix, which will have consequences for every other thing we do, is largely determined by the dynamics is dominated by the smallholder agriculture, which is widespread, small holdings of agriculture, extensive non-timber forest product extraction, widespread commercial and non-commercial timber extraction as well, and high rates of agricultural abandonment. Now, all of these problems, have implications for resilience, right? In terms of all of these will be affected by climate change too. So, what is driving these dynamics? Of course, there has been population growth, but poor agricultural productivity, which I want to flag in particular, is extremely important as a driver. Then there's, of course, international support for developmental projects and so on. So the drivers, cut both ways. Some are positive and some are negative. Like there has been fairly successful community forest management programs that has probably led to the recovery of many areas that we see as regrowth of forest. But there's also other problems that we have sort of highlighted here. And of course, climate change is a looming large problem that's going to change forest dynamics as well. So it has a reciprocal impact. Now, what does deforestation and degradation do that affects resilience? One is it contributes further to climatic changes, right? So there's a feedback effect of that. It alters the hydrological cycle, water balance, and affects soils, which affect agriculture, which affect every other livelihood option that people have in the Himalayas. And then, of course, extreme events, and then ecological services that people depend on a lot over there, from provisioning services to pollination, pest control. Then, of course, loss of biodiversity and loss of the gene pool, which is hard to really quantify in monetary terms, but it links up nicely with ecological services as well. And then pests and invasions that alter the ecosystem. Now, all of these are exacerbated by climatic change, which itself drives disturbance, and it simplifies communities when communities get disaggregated, when species move, and then actually causing the extinction of local extinction of species. All of these will contribute to these problems. Now, I'll stick to the forest component a little bit and say, what can we do to promote the resilience of the natural ecosystems of the region? Because if once those are resilient, it really helps with other ecosystems. One is to reduce the threats, of course, then avoid fragmentation and improve connectivity, because ecological processes are better maintained and if forests are not completely fragmented. And then in terms of planning and thinking and management, you need to look at a larger unit. We can't look at small units. We need to look at landscapes and regions and plan for the entire region in order to build resilience. And then we also need to maintain buffer zones for important areas. We need to soften the hard boundaries. We need a proper buffer zone between intensive human use and ecologically rich land, regions. And then we need to preserve ecosystem structure across gradients. The Himalayan region is full of gradients, environment like elevation, for example, or other climatic gradients. We need to preserve that structure. Otherwise, you're not going to have the full range of habitat types, and you will not be able to derive the full range of benefits. Protect old growth forest. We really need to do that because very little is remaining, and it's remaining only in some inaccessible sites. And protect ecologically important species. Maintain fire regimes and that are natural to the systems, particularly in the Western Himalaya, and then prevent outright conversion to plantations, really, because they cause problems, and I don't have time to go into that, but the better option is to do low intensity forestry and agroforestry. And then, of course, take up restoration of degraded sites. There's a lot we can gain from restoring sites that are already quite degraded, right? So these adaptations that are there to promote resiliency in these systems would directly impinge on our ability to decrease population pressure, to sustain an increase in agricultural productivity, strengthen institutions that protect forests and manage forests, and leverage other economic activities such as tourism and all of that, and then transitioning the fuel economy or energy. And by trying to establish other sources of fuel wood for people and so on. Now, briefly before I close, I just wanted to say something about agriculture, because this is a primary livelihood for people in that region. Now, I'll just take Arunachal as an example for the sake of brevity. You see, agriculture is the main livelihood in this region. It's a fairly large region with multiple agroclimatic zones, but 85% of the people depend on it, but it accounts for only 25% of the GDP. Now, agricultural incomes are low, and there are serious problems with regard to the difficulty with agroclimatic conditions, topography, soils, primitive methods, low investment in capabilities, and so on. And then, of course, climate change adds to that big problem. And look at the number of dams that are being proposed, as you'll see over here. These will alter things further in ways that we don't understand. So there are a bunch of ways in which you can actually improve, agricultural resilience. And clearly, the climate changes are going to impact agriculture in the Northeast, in the Himalayan regions tremendously, because they are mostly rain-fed. And of course, irrigation potential will increase in the future because of all the dams. But this is going to happen.
Robert, can you hear me?
Yeah.
Our time's almost up.
Okay, so I'll skip a couple of things, and I just wanted to highlight finally. So there is a lot we can actually do with respect to managing water in this region, because that's related to the dams that I was saying and energy that I was also mentioning about hydropower being projected as clean energy. But finally, I think what we really need to do is to think of resilience enhancing systems that are already known from the region, like agroforestry systems or multi-cropping systems that are really well known to people, rather than intensification of agricultural systems. So here is the last slide that I wanted to show with with some interesting linkages. So what we want at the end are climate resilient communities. And you see the linkages with forests and agriculture, livestock, and all of these can contribute to a system of integrated land management with respect to both land resources and water resources. And unless we do that, we will never be able to build resilience in the way that we'll actually want to if you look at it individually by individual sectors. So I kind of stop there. I have to skip over some things, but that's all I have. And thank you for the opportunity and for listening.
Thank you, Robert. I'm so sorry for interrupting you.
No. I had a long response.
Yeah, I really wish if we had a half an hour, but unfortunately, there's another symposium waiting at 6:15, so we need to move over. I think we have 3 questions that came, but I think I'll reserve them for the end of the symposium. If we have time, we will discuss that. Thank you so much, Robert.
Yeah, thank you.
Yeah.
Right.
You can stop sharing. Yeah, you can stop sharing, so the second speaker can come up.
So how do I stop sharing?
Just go up, and you can see the
stop video.
Yeah.
Stop video, is it?
Yes.
Okay. So is it done?
No, it's still not done. Yeah, now it's gone. Yeah, thank you, Robert.
Thanks.
Now you can see your nice face. Okay, now we move on to the second vulnerable landscape, that is Sundarbans. As you all know, these landscapes are vulnerable, and it's very culturally important landscape for Bengalis and Bangladeshis and for the whole India as is concerned. And we have the speaker, Professor Silanjan Bhattacharya, and the Silanjan Bhattacharya, a professor at West Bengal State University, graduated from Indian Institute of Science long ago. He has about 35 years of experience as a researcher and teacher and professor, and he was a key member in Professor Gadgil's People Biodiversity Registry events, and he had done a couple of postdoctoral work after his graduation from IISc in Stanford University and French Institute. With this brief introduction, I'm so sorry, Silanjan, I could tell more, but unfortunately we don't have time. I hope you can stick to time.
No need. Thank you for giving me this opportunity and the kind introductions. From Robert's highest landmass on Earth will come down to the lowest areas where humans inhabit, Sundarbans. Sundarbans, Senuk, if you don't mind, if you can say, let me express my apology that somehow my computer MacBook has betrayed just 1 hour ago before this event, and I couldn't show you the PPT. We are now becoming handicapped without PPT. Anyway, I have sent a few photographs to Sinu to help. Most of my talks will be without the aid of PowerPoint pictures. Just to tell you, I hope many of you know Sundarbans, at least where it is located.
Sinu, make it full screen, Sinu.
Yeah. Yeah. So, Sundarban, if you look at the global map in India, it's one small dot. It will appear on the tip of the Bay of Bengal. It's a funnel-shaped end of the funnel, and it covers at present both Bangladesh and adjacent West Bengal. It's lie at the sea surface of the Gangetic Brahmaputra Delta. Approximately 60% lie in Bangladesh. It's a more active deltaic land, and 40% in India, that is in West Bengal. It's actually, if you go through the literature, it's really significantly large and the largest single patch of mangroves on Earth, especially if you consider it as Australian mangroves. The next to it is Pitans in Mekong Delta, surviving most of the deltaic mangroves on Earth have been removed for agriculture and other human habitation. Luckily, it remained. That's because of the active deltaic activities of land formation by the greatest riverine system on earth, that is the Ganga and Brahmaputra system. Unfortunately, what the cover remained, say, some 200 years ago or even 150 years ago, only a part of it remained today. Most of the parts since 1875 onwards up to 1975, within 100 years, have been reclaimed for agriculture and agricultural settlements. The remaining part within West Bengal would be not more than 4,000 square kilometer area. And adjacent to it is a large reclaimed human habitat area. If you look at the picture, there is a red border on the north, which boundary the area. This is the original Sundarban at the beginning of the previous century. And this is the intertidal land. That means every 6 hourly, the water, the brackish water or the salt water floods the landmass, and next 6 hours, the land gets exposed. So between two tides, the land exists. And this is the particular habitat for a group of plants who are uniquely adapted to live here. Not many species could do it in evolution. It's a result of what biologists call convergent evolution from different taxa, a few family members, not many family members from all family, in any family, invaded this land with unique adaptation to survive against the flush flood of tidal waters, against the salinity, against many other factors which are quite aggressively detrimental for other plant communities. And as the plant communities, that is mangroves, grow here, it creates a unique ecosystem which allow other biodiversity, which is unique to the region, to survive. So biodiversity-wise, it is one of the very important region on Earth. And if you look at the role of mangroves, why they are important, I will come to the global warming issue at the end. But before that, keeping aside the issues of global warming, sea rise, what are the roles mangroves played in our life, especially those who live in the deltaic lands? Apart from global importance of biodiversity this community has, physically, mangroves provides a wall to the people living inside, to the ecosystems living behind it, away from the sea. So it stands as a barrier between the sea and the inlands, highlands, and resist the atrocities caused by sea waves, cyclonic storms, and other saline bad effects towards the freshwater inland habitats. Not only that, it gives land to the inlands. Mangroves, for their survival, grow very dense by inserting their and spreading their root networks inside the mud of the intertidal zone so that they are not flushed out by the tidal forces. And this dense mass also resists the cyclonic storms and tame it before that reaches to the sea. But at the same time, this root network makes the tidal water flowing through it slower. As a result, the silt carrying, that towards the seamouth, the rivers in the estuary carries maximum amount of silt. And in an estimate, you can assume that this great river system, despite trapping silts by the mangroves, deposit nearly more than 1 billion ton of silts into the Bay of Bengal every year. So the amount of silts you can think. What mangroves that root system does, it slows down the water flow. As a result, silts store and deposit it at a faster rate on the land mass, which is below the water. As a result, lands come up very fast and mangroves speed up the land formation. And once it is above the tidal level, what is called supratidal zone, it becomes freshwater zone. And mangroves themselves cannot survive there. Mangroves walks towards the sea. This is a very common factor. Maybe Robert and Rennie or someone who is expert in ecology, mangroves, this is very common knowledge. But for general audience, let me repeat this. Along with that, mangrove provides nursery beds and breeding grounds, safe breeding ground for both seafaring freshwater species or migrating species from the sea. As a result, the aquatic biodiversity, aquatic productivity of natural resources like fishes and shellfishes are very high. And humans who are living behind the mangrove zone have been exploiting these resources from the time immemorial. As the mangroves are walking towards the sea and gifting the plants to be reclaimed by the normal agriculture, it is happening. This service is a very well integrated system with the deltaic agricultural ecosystem and the civilizations. And now at present context, mangroves has been recognized as another important biosystem. That is a major part of the what is called blue carbon deposits. They are recognized as one of the best ecosystems to sequester the carbons from the environment and deposit in their organic mass, in their soils and above soil biomasses. So, including all this importance, mangroves are extremely important for the survival of the people who are locally living behind them. And in terms of carbon sequestering, and biodiversity, it has importance of global scale. And another important point, another interesting and important point for mangroves is its capacity to come back, that is resilience. I'll come to that. One of the most aggressively resilient plant communities, I think, as per my knowledge books. If you consider the vulnerability point, I will not detail, I will not go much, I will end up in a short thing and let the discussions go on. If you think of Sundarban's vulnerability to the global warming and sea level rises, assume that it is increasing by more than 1 centimeter per year as the NASA satellite data suggests, or whatever we think. Within 30, 40 years, we'll be flooded, those who are not only living within the intertidal zone of Sundarbans, but also adjacent above it. As an inhabitant of Calcutta, we have been warned that we may go underwater, the city may go underwater. Now, what might happen to Sundarbans? Let us see. What will happen to Sundarbans? Mangroves ecosystem, the natural mangrove system, which are now protected as natural national parks, sanctuaries, tiger reserves, other reserve forests. I don't think any problem this community will face. Because if you dig out the past history, you will see mangroves has always adapted to the sea change in the geological history. Either it crawled forward or it crawled backward. And give it a piece of intertidal land within, in terms of ecological scale, even within a splash, it will occupy it and flourish there. Even those who work in Sundarbans, they can show you the areas that within 1 or 2 years, how the mangroves have restored itself once an undisturbed patch is available. So, in terms of mangroves and mangrove inhabitants also, because where the mangroves will go, the mangrove inhabitants will go. So,
Professor,
hello?
can I interrupt? Professor Silanjan, you have another 4 minutes.
Okay, I will finish before that. Will go. The problem is with the people who are living this yellow zone, because they are living inside the originally intertidal land, and already protected by the earthen embankments, about 3,500 kilometers long in the sun. Embankments protect their land, make them artificially freshwater habitat so that they can cultivate, they can build their living areas. But if, as you can see, the vulnerability in different colors, yellow being the most, the dark brown, this red zone, dark red zone being the most vulnerable, then to the pink zone and to the yellow zone. These areas are protected. They are surviving under the embankments. But once the sea level rises, it will go. It will be flooded. And this area sustain 4.5 million people. You don't have area anywhere to replace them. You cannot remove them and rehabilitate them altogether. It is almost impractical. But theoretically speaking, if you can replace them and rehabilitate them somewhere and allow these embankments to be flooded, broken and the lands flooded, within my estimation, within 20 years, 2 decades, the entire will be covered by mangroves and it will be good for people living behind. That's not possible. That is a practical, sociological, socio-political problem, not ecological problem. And how do we sort that? Because the mangroves cover, if we keep, not only help us to fight against the cyclones, fight against the erosions, but it will provide us increased natural resource bases, and in today's terms, it will provide enormous employment in terms of ecotourism. There is only solution to all these problems: increase the mangrove areas. There are a lot of unplanted, exposed mudflats due to human disturbance, which can be brought under mangrove covers easily. Forest departments and other agencies are working to raise mangrove plantation there. I applaud their efforts, but at the same time, I want to suggest that the mangrove, not plantation as we know in recent years, the plantation cannot bring back the original community, and many a time it becomes failure. So at the same time, we have to sustain, just 1 minute. You have to sustain the regeneration, natural regeneration also. And once it is done, we have to develop the salt-resistant varieties which were previously available in the region, to bring them back and allow and brackish water-based aquaculture and paddy cultivation altogether to those people. And this has to be explored. This might be the only solution, and increasing the mangroves we can tackle the sea level rising problem due to global warming. Thank you very much.
Thank you, Professor Silanchan, for talking almost what we need to know to conserve this mangrove forest and its vulnerability in the scenario of the climate change. Okay, thank you so much. And now we move on to the third landscape of what is impacted from the climate change is nothing but the one which we see in the southern India, that is Western Ghats. We got a very eminent speaker, Professor Rini Borges. She was involved in this recent Western Ghats ecological expert panel headed by Professor Madhav Gadgil. Rini Borges was the chairperson of Indian Institute of Sciences Center for Ecological Sciences, and she is the head of many chairing many governmental bodies related to the environment and science and technology activities. And she got her PhD from University of Florida and had more than 40 years of research experience in scientific science. Short of time, Professor Rini, may I request you to stick to the time because we have to wind up by 6:50. Thank you. Over to you.
Yes, of course. Sinu, thank you for that very nice introduction. And I'll go quickly and finish in 10 minutes. Don't worry. So let me see if I can share my screen. Can you see this?
Yes. You just enlarge it, please. Full screen.
Right. Okay. So if you can see it, right?
Yes.
Okay. So as Robert has given us a wonderful introduction to all the issues and the rise in temperature and so on, and he has really set the stage, and then Silanchan took us into another very vulnerable landscape, which is so important for us to protect in terms of erosion and, protection from environmental calamities like cyclones, etc., which are very prominent in the Bay of Bengal. So I'm going to talk a little bit about the Western Ghats very briefly. And of course, you can see the Western Ghats in this beautiful image, which is a sort of a spine. It's like a vertebral column which runs down the west coast of our country. And we have, of course, the central Indian plateau, but we have all of the hills of the Western Ghats. India is a very hilly country, except for, the Gangetic plains that Robert was talking about, which all the rivers in India bring all the silt, which then ultimately gets deposited in the Bay of Bengal, which connects to what Silanchan was talking about. So if one looks at protected areas, for example, because, today in India, maybe some of the original forests, Robert talked about the old growth forests, may exist in some protected areas. And I just pulled this out from a recent NVIS publication, which tells us as of December 2020, just 5% of India's land area is actually under protection. So you can see all of these dots, and several of them are in the Western Ghats. But if you sum up all the area, it's really very minuscule. So we can't really expect that our protected areas are going to give us the kind of, resilience or protection for biodiversity that we really require in the country. So if we take, the Western Ghats itself, and there is one particular montane forest, grassland transition area, which is very, very special in the Western Ghats. And these are sort of marked by red in this slide, and you can see it goes from the Baba Budan Hills and then goes all the way down to KMTR Sanctuary. And some of it is in protected areas, but a lot of it, as I said, falls outside. Now, if the prediction is that with climate change, things are going to get warmer, so you might expect species, even plants and other organisms, to try and migrate up the mountain. But slowly, there will not be any, area for those species to sustain themselves. And of course, as very nicely termed, this is really likely to be an escalator to extinction. So if we look at this beautiful forest mosaic and grassland, which is very, very typical of the southern Western Ghats, it's really a remarkable landscape, which is very, very sensitive to disturbance. And as you can see, it holds some of the most unusual and unique species of plants and animals, many of which are also serviced by pollinator species that also deserve to be protected. Otherwise, this landscape in its entirety will not, remain for posterity. This, of course, is the Nilgiri Thar, which I will be talking about a little bit later. Oh, just in the next slide. So this is really very interesting because you can see that in India, we have two disjunct populations of plants and animals, which are very closely related to each other. You have the Himalayan Thar, which is distributed in this part of the country, and then in a very small pocket, you have the Nilgiri Thar, and the same kind of distribution is also shared by the rhododendrons. So people talk about the Nilgiris and the Himalayas being certain areas in the Himalayas being sort of refugia for these montane species. You will not find these species anywhere else. So already in the past, we have had these mountains becoming refugia, and now with climate change, we're going to perhaps have even greater stress because species are going to try and move upwards. And this is the prediction. So you can see that with global warming, you can get cascading effects. You have plants that are serviced by pollinators, and then you have other organisms that feed on these insects. And we really know very little about the thermal maxima that these cold-blooded organisms like bees, how they are able to sustain. And we have very, very little modeling and very little actual practical information. So the predictions are that there could be a cascade of extinctions which happen when any one of these network connections is broken. Similarly, as I've said, you have species moving up mountains. You have maybe one species moves up, but its partner doesn't move, and many species that are actually coexisting because of partnerships. If you have a mismatch in the partnership because of global warming, this can be a very bad thing to happen. So we, of course, know that we are in this very peculiar era called the Anthropocene, which is an era which is dominated by human effects. And as Robert mentioned, the human effects on climate change are enormous. And with a few of the species that people have looked at, you can see there is a dramatic decline. And these are actual declines that have been mentioned. And over the whole globe, there is a huge decline in the insect species that people have been able to record. So this is extremely worrying. And therefore, one wants to ask the question, how can we replace these gardeners of nature? Here you have, an extreme example in China, where a lot of the pollinators have vanished, and manual pollination of apple trees and peach trees is being undertaken. You can, of course, have plantations and restoration to try and get back to this original scenario, but that's very unlikely. So this is from managed tea gardens in the Western Ghats in the Anomalais. And here you can see tea gardens and just pockets of this original vegetation. Now, obviously, as Sinu said in his introduction, tea in South India, they remove all of the covering. Very, very few natural trees are left. And so you are left with these fragmented forests. As a matter of fact, if ever next time the Bengal Chamber of Commerce does have this again, I would advise you to call two of these wonderful people to talk about forest restoration, because this is really a flagship project where Divya Mudappa and Shankar Raman have actually attempted to restore these fragmented forest, abandoned tea plantations, and doing the work of what the native hornbills would actually do. So this is a really remarkable story. And so therefore, you know, these forest montane grassland areas, that's what you see maybe during the day. But if you look at what's happening in the night, this is another very important disruptive force. And this is artificial light at night, which is destroying the rhythms of life. And there are many studies now which are showing that even the so-called species that are living far away from these disruptive lights are unable to breed because of this. So this is an area where a great deal of intervention is possible. Sinu mentioned the extreme weather conditions and the floods in 2018 in Kerala and in Coorg. And this graphic actually describes this. These are the number of landslides, these peaks, the red peaks, and the Western Ghats experienced 6,970 landslides in a single month in August of 2018. So we had huge amounts of unprecedented rainfall, land erosion because of unchecked building activity, and consequently landslides. A NASA image of this same period shows you in August the situation compared to the regular normal situation many months prior to this flooding event. So this is really unprecedented, and this is what is going to happen in the Western Ghats if we are not careful. My last example is about, I know that we have had talks on sustainable energy, and these are a whole group of wind farms that have been set up on the plateau in Satara in Maharashtra. But although I'm, supportive of sustainable energy, the point I'd just like to make is that these are giant constructions and giant booms that have to be moved into pristine areas, sometimes on the top of mountains. Now, to carry these giant structures, temporary roads have to be made, which just compounds the soil erosion. And we know for sure that transport of these booms is a major cause of soil erosion. So I think the costs and benefits of these things have to be balanced if we are talking about a sustainable future. I just want to wind up by saying that it's very important to do cumulative impact assessments. I know with personal experience, having been on the Western Ghats environmental expert panel with Professor Madhav Gadgil, that a lot of companies set up and try to push forth their plans without and breaking up the windmills into smaller and smaller companies, although they are all one big conglomerate. And unfortunately, our environmental impact assessments do not do cumulative impact. So they don't take the entire impact of all these smaller windmill farms which have been proposed. And this is really something that we should go towards. So I'm going to end my last slide saying that ecological costs must be factored into the value of commodities that we source from the Western Ghats. I mean, wind energy is also a commodity. It's also something that the Western Ghats is providing. This is the only way that we will get sustainable commerce and sustainable ecosystems. Thank you very much. I'm done. So I will stop sharing.
Thank you so much, Professor Reni. Such a wonderful, well-tailored presentation. I think you have finished. You have good messages for the industry partners, because this is a cause, I think, why you included the slides, I think, particularly on the windmills and other industries which are popping up at the cost of the forest over there. We heard from the authority who walked along the length and the breadth of the different words, Professor Reni Borges. Thank you again, Reni, for pointing the case of Shankar Raman's initiative. I remember when I joined in 2006-07, they initiated the program, and I'm so happy to see that forestry came up well. Again, a good example the industry can take up, they're using their abandoned landscapes around, to protect a small green islands. So thank you so much. With this, I think I'm going to wrap it up. Robert, you have 3 questions and a couple more questions for Reni, but I think I'm not going to read it out now because we have only 1 minute for the next symposiums to start. I'm so sorry about that. My concluding remarks is that, it's so good that the industry has come up with such a good symposium. That's a very good gesture, because in the policy decisions of the industry, we can't it's a required parameter actually to take the decisions in Government of India. I think this small symposium, I hope, might stimulate you to further partnership with the scientists and researchers, particularly ecologists and activists involved in the conservation of our landscapes. Thank you so much for covering 3 walls of India, the Sundarbans, the Himalayas, and the Western Ghats. And I hope this will give you a lot of good messages. Thank you so much, all the speakers. Over to you, Jayanta, for wrapping up.
I think Dr. Shenu is a wonderful experience to hear from the 3 experts from different geographies of India. It is a real learning for all of us actually. And the questions what we have received, we will mail it to you so that we can get it from the respective speakers, and we can post it to our website and to the concerned BBC. But it is a real learning, and sincere thanks to all of you for your excellent presentations. Though time is very short, but definitely we'll be looking forward to hear from you in upcoming seminars also. And thank you, Dr. Sinu, for your moderating the entire thing. Thank you very much. Thank you.
Thank you. Namaste.
Thank you, Mr.
Thank you.
Thank you. Thank you very
Bye.
much. Bye.